Hello guys, in this video I will teach you how to create a paraglider ability in C++. So let me show you how it works. So if I jump here and I press a button, I'm able to glide around, and if I land I go back to normal. Alright, so to start off we're gonna need a third person template and make sure it's in C++ and create your project. Okay, now we have the project, and also the project solution was created and it's opened up now, so we can start working on this. And let me test this. So this is what we have now: third person character that we are able to walk around, and we will build the paraglider on this character. So if you go to the third person folder and open up your character blueprint, you can open the parent class, which is in C++. Here it is. We have all of these code for moving around, and we will add some logic to it. The first thing we're going to add is an action mapping for toggling the glider. So here under the jump action, we will define a new action. So U property in parentheses. Actually, let me just copy paste this. I don't need to write. We're gonna say class U input action gliding action. And now let's go to the CPP file, and here under the input function, under the jump action, we will define a new gliding action. So enhanced input component, the arrow operator, and find the bind action. It's very similar to the above, to the jump action. So open the parentheses and we call it gliding action. It is a E trigger started, and we get a reference to this class, and we use the AND operator to find the function that we need to call, which we haven't defined yet. So let's go back to the header file and we will define a new function here. So void toggle gliding. So right click, go to quick actions and refactoring, and create the definition in the CPP file. This is the function we're going to call. So we're going to say a tutorial character colon toggle gliding. So let's compile this. I will close down the editor and start the debugging. So now that the compile was successful, go to the third person character blueprint, and here if we look for gliding action, we can set up a new input which we haven't defined yet. So we have to create one of these, and let's do that. So go to the third person input actions and just duplicate one of these, the jump action, and rename it to gliding. Open the input mapping context, and here create a new input and choose the gliding. And for the key, click this keyboard and press F, and now it's complete. So let's go back to the third person character and choose the gliding option. So now our input is set up. So here in the toggling, this is where we will set up the functionality for gliding. So the first thing first is we want to check if the player is already gliding, and for that we need to create a new boolean, a variable. So let's create bool is gliding, and the default value is set to false. So here, if b gliding is false, we will start gliding, and we want to create a function for that. So go back to the header file. Here under the protected section, create a new function, void start gliding, and also refactoring and create a definition. So if it's set to false, we will start gliding, or if we are already gliding, we will stop gliding. So let's create a new function, void stop gliding, and do the same thing, create a definition, stop gliding. Now for the gliding function, let's create our logic here. First, we want to check if we can start the gliding. We want to check the condition for gliding. So we want to check, actually let's create a new function for this. It's a boolean. The function must return a bool. So bool can start gliding. So we want to check if can start gliding is true. And if it's true, first thing we want to store the velocity of our player. So let's create a new variable, f vector, because velocity is stored as a vector. So f vector current velocity. We want to store the velocity to that variable. So current velocity equals get character movement, and use the arrow operator to find the velocity. So velocity, here it is. Now that's done. We want to set the b, the boolean b is gliding to true, equals true. So now for the gliding settings, we want to change the properties of our character movement. We want to be able to fly at a low speed. So let's get character movement, arrow operator, and set the rotation rate to 0, 250, and 0. Also, I forgot to put an F rotator here. So we want to set the rotation rate to 250. This is the speed of the character rotating to the direction of your input. I found that the 250 is good for this purpose. So next, we want to change the gravity so that the player starts to fall slowly. So get character movement, arrow operator, gravity scale, and we want to set this to 0. Next, we want to change the air control. So again, get character movement, arrow operator, and set the air control to, I found the value of 0.9 to be good. So 0.9 is good for me. Next, let's get the character movement again. We want to change the braking deceleration. So braking deceleration falling. We will set this to 350. These are the values that I have found to be good. If you want to change these, you can do that as well. But I have found that these values work well for me. Let's get the character movement again, and let's set the max acceleration to 1024. The next thing, we want to set the max walk speed. So max walk speed to 600. And also, we want to set the control desired rotation to true. Get character movement, and B, use controller desired rotation. The description says, if true, smoothly rotate the character towards the controller's desired rotation. So we will set this to true. So these are the essential values for the character in order to start falling. However, we need one more thing here. We want to record the original settings of these, because if we want to stop gliding, we don't want to type this whole thing out. We want to just call a function, and this will set everything back to how it was before gliding. So let's create a new function here, void record original settings, create a definition, and here we will store the value of these variable. I have already prepared the variable. I didn't want to type this whole thing out. So you can pause this video and create these variables. The first one is a boolean original orient rotation. The next one is float, original gravity, original walk speed, original deceleration, original acceleration, and original air control. And also another boolean for original desired rotation. You need to create these variables. Here we will store the value of our character in these variables. So original orient rotation equals get character movement, B, orient rotation to movement. I will probably fast forward this. Okay, now I have type this out. So original gravity scale, call the character movement and get the gravity scale. Air control, do the same thing, use the arrow operator and find the air control. For deceleration, also the same thing, braking, deceleration, falling, and the same goes for acceleration, walk speed. You will get the variable from character movement, and last one, the desired rotation, which is a boolean. And now that we have stored these in a variable, we will call the record original settings here in our start gliding function. Let's go down to the function for can start gliding. The first thing we want to check if you're able to glide is check the height of the player. So we have to be falling from a surface, and we have to be above a certain height. We don't want to start gliding while we are close to the ground. We want to do that by using a line trace. So f hit result hit, we will store the result of our line trace in this variable. So first we're going to need a starting location. So f vector trace start equals get actor location, get the location of our player. Next we want to get the end location. So f vector trace end equals get actor location plus get actor up vector. So the up direction and multiply this by minimum height. So actually let's create a variable for that, because we want to change that during game. We might want to change the height to something higher or lower. So create a float. Minimum height, the default is, let's say, 300. So we want to multiply this by minimum height, and we also want to multiply this by -1, because when we get the up vector, it's going up, but we want to check for the height below the character. So if we multiply this by -1, the trace will go down instead of going up. Next, create the collision settings. So if collision, what was it called? If collision query params, call this query params. This will be modified by the trace function, so we don't need to initialize it. And also use the query params to ignore this actor. So add ignored actor this. We want to ignore ourselves. We don't want to hit ourselves by doing a line trace. Next, we have to create the collision channels. So t enum as byte. Use the brackets and type e collision channel, and we will call the variable trace properties equals ECC. We want to trace in visibility channel. We want to trace for anything that's visible. So after this, we are now ready to do our line trace. So get world. This is where the line trace is called from. Line trace single by channel. Open up the parentheses, and the first parameter it takes is the f hit result. So say hit. Next, the start location, trace start, which we just created. End is trace end, and let's use the trace channel variable that we just created. What did I call this? Trace properties. Trace properties. Next, input the query params, and that should be all we need. And also let's do a debug line. We want to see where the trace line is going. So draw debug line, get world, trace start, trace end. We want to see if we hit something. So hit dot blocking hit. If it's true, if we hit something, it's red. But if we don't hit something, we will use the blue. No, not blue. Red. We want to use the red color if we hit something. And the rest of the parameters are set by default, so we don't need to worry about that. Actually, I forgot here. You have to put a colon here between the colors, because this question mark is if a statement, and if you hit something, it's blue, and if you don't hit something, it's red. If you don't put this, you will get an error. And now, after doing all of that, we will check if we hit something. If blocking hit equals false. If we didn't hit something, that means we are above the minimum height. And we also want to check for the state of the player. We have to be falling, so we use two and signs, which is an and statement, and we will get the character movement and check if we are falling. So is falling equals true. Don't forget the parentheses. If all of this is true, then we will return true, and if it's false, else we will return false. And also delete this. We don't need this. Okay, so that's all we need for the function which checks if we are able to glide. Okay, so let's test this out. Let's stop the debugging and save everything and run the debugging now. I will create a new, place a new object here, and also make it very tall, and you move the player start on top of it. So if we start playing and we press F, we can see that the settings have changed. I'm going up because the gravity is 0, so I'm going up. That means that the input and the settings are working. I'm floating above, so it's all working. But that's not what we want. It's not done yet. So because we set the gravity to 0, we have to descend the player ourselves. I've realized that by setting the gravity to something like higher, you don't get the desired outcome. We have to do this manually. So let's create a new function. Void descend player. Create the definition, and here in the descend player function, we want to check if the current velocity which we just stored, the z-axis is not equal to the descending rate. Let's make that variable too. And also let's use the U property, so we are able to change it from the editor. So U property, float descending rate. Let's set the default to 300. I'll go back here and we want to check if it's not equal to descending rate multiplied by -1, because the descending rate has to be something negative, not positive. And also check if we are gliding, because this function needs to be called from tick. So if this is true, we will descend the player ourselves. So current velocity, the z-axis, equals, we want to call the f_2 function. So let's go here in the header files. At the down below, we will include the necessary header file. So it's called Kismet math library .h. This is where we will call the function, the f_2. So let's call our function u Kismet math library : f_2. The f_2 smoothly goes from the current value to the target value, and we want to descend the player smoothly. We don't want to suddenly set the velocity to something like 300, because it wouldn't look good. So open up the parentheses. Current velocity takes a float, so current velocity dot z, which returns a float. The descending rate, it's the target, and also we have to store the delta. So go here to the header file, and down here call virtual void. We want to override the tick function. So void tick, and it has a float delta second type override to make sure that we are overriding the correct function, and create the definition for this. Here's our tick function, and also I forgot to, we have to store the delta. So float delta, and we use this variable to, so we store the delta seconds in this variable. So delta seconds, delta equals delta seconds. So come down here, type delta, and the last parameter is the time which takes to set our velocity to the current target. So let's set this to 3 seconds. You can set this to whatever you like, but I have found that 3 seconds is good. Next, we want to set the velocity of our player. So get character movement, and use the arrow operator to set the velocity, the z direction of our velocity, to the descending rate, multiplied by -1, because it has to be negative, not positive. So it equals the descending rate. So let's compile this, stop the editor, save everything, and run the debugger. So now let's test this out. If I press F, I go down very slowly. The gravity is still messed up. That's because we haven't set up the stop gliding functionality. So in the stop gliding, we want to apply the original settings to our player so that he will start walking normally again. So let's create a new function. Void apply original settings. Let's create the definition. In the apply settings function, we will define the logic for setting everything back to how it was. So get character movement. We will do the same thing that we did in the records function. So set the orient rotation to movement to original orient rotation. I will speed this up so you don't have to watch everything. Okay, now I have set everything back. This is the result, and in the stop gliding function, we will call this. So apply original settings, and also we want to set the B is gliding to false, and that should be it. So we are able to toggle the gliding. So let's stop this, save everything, and run the debugger. So now if I start falling and press F, I go into gliding mode, and if I press F again, everything goes back to normal, so I'm not floating around anymore. But if I press F again, I start floating, and I go down. And also I forgot to call the function descend player from tick. So descend player has to be called from tick. And also we need to define, we need to create a mesh for the glider. So come to the header file, and here, up here, we will create a new variable. So you actually just copy this U property, and we will create a class. Actually, forward declare the class. We don't need to create a class. We call the U static mesh component, and it's a pointer, and we'll call this glider mesh. So let's initialize this in the constructor. So come here and type glider mesh equals create default subobject brackets U static mesh component, and open the parentheses, text, open the parentheses again, and call this gliding mesh. So this gets initialized, and we will attach this to our root components. So set up attachment, the root component. That's all for the constructor. And in the begin play, set the glider mesh to invisible. So glider mesh set visibility to false. So we are not, by default, we will not see the mesh. And go down here in the start gliding functionality, and at the beginning, set the mesh to be visible. So set visibility equals true. And likewise, in the stop gliding, set the mesh to invisible again. Set it to false. So stop the debugger, save, and run the debugger again. And if we open up the character blueprint, we will see that the glider mesh has appeared here. And I have prepared a mesh to use for my glider. So if you, this is the mesh that I will be using for my glider. You can use any mesh that you want. And also, I have prepared an animation for the gliding. It's a simple animation. It's just hanging from the glider. You can use any animation you want, but this is what I'm going to use. So go to the third person character blueprint and click on the mesh and use the glider mesh. I will bring this up here above the head, and also we have to use that animation when we are gliding. So I'm going to use the animation asset park glider idle, and I will bring this down just a little bit so that it lines up with the hands of the player. It's looking good to me, and I will set it back to animation blueprint. And we also have to open up the animation blueprint and set up the logic for changing the animation while we are flying, while we are gliding through the air. So this is the default animation blueprint. I will get a reference to my character from the character, and I will cast this to tutorial character. That's the name of my class, and I will store this in a variable because we will need this to change to use in our animation graph. So let's go to our animation graph, and let's go to the main states, and on the for loop we will create a new state. I will call this gliding, and I will open this up, and from the asset browser I will look for my paraglider animation, drop it here, and connect this here. And for the condition, we open up this condition blueprint node and use the reference to our character, and we get the variable is gliding, which we have to expose to our blueprint, which we haven't done yet. So come to the source code and copy this U property and paste it above the variable, and also change this edit anywhere to visible anywhere, because we don't want to be able to edit this from the blueprints. We just want to see the variable. So let's close down the editor, save, compile again. So we get the reference and we check is gliding is available, and we will use this in our condition, in our as boolean. So if we are gliding, we will transition to this state, and if we are not gliding, we will use the opposite of this. So not gliding. No, not this. Not boolean. And this should work, I think. Okay, so the animation is working. And then when I press F, it goes back to normal. But the mesh is not coming. Let's see why. Okay, so the problem was that the the mesh was cleared from here. Not sure why. I just had to set it back, and now it's working. If I jump and press F, here it is. This is kind of working, but there's a problem here. Look, if I land here, I'm still in the gliding mode, and we don't want that. We want to when we land on the ground, we want to go back to normal, and that's something we haven't done yet. So let's go back to the code, and here from CPP, and under the tick function, we will check. We want to see if we are walking on the ground. So we will get character movement, and we want to see if we are walking. So is walking is true, and we are also gliding. So P is gliding is also true. If this is true, we want to stop gliding, and that should be everything, I think. So let's close this down one more time. Oh my god! And let's compile it again. Oh, okay, so now the final test. Let's see, if we aim to jump, press F, and it looks like it's working. Let's see if we land, and it seems like the functionality is working as well. When we land, we go back to normal. And also, if the height is too low, we are not able to toggle it. We have to be higher than the floor. We have to be at the minimum height to be able to toggle the gliding. You could set that variable from here. Let me see. If I search for minimum, you will see that the variable shows up. The default is 300. If I set this to something very low, we will be able to toggle it at a low height without having to jump. But if I set it to something high like 300, we can't do that anymore. We have to jump from a distance to be able to toggle this. Okay, so that's everything that we need to do, and it seems like it's working. Thanks for watching, and have a good day.